Tiga.
Okay. So today we will continue with the chapter 7, that is multiple linear regression. Okay. So in this chapter, let's take a look into the learning outcomes. Okay. So at the end of this chapter, you should be able to determine the regression analysis involving multiple variables, develop the multiple regression equation involving linear and quadratic case, run the hypothesis testing for multiple regression coefficient, and analyze engineering data using multiple regression analysis. So if you still remember, in chapter 6, we learned about simple linear regression. Okay. I wish in chapter 6 we have the equation of y equal to a plus bx. Okay. So in multiple linear regression, so you have only one independent variable. In this case, you have only one x. But in this multiple linear regression, the idea is you have more than one independent variable. So you have y equal to a plus bx1, b1 x1 plus b2 x2 and so on. Okay. But for this syllabus, it will be limited up until two independent variable. Okay. You have x1 and also x2. So the idea is, our aim is actually to develop the regression model for this one. For y equal to a plus b1 x1 plus b2 x2. So how you are going to develop this model? So let's take a look into the, what we call it, the basic idea. The regression analysis is used to describe the relationship between a set of independent variables and the dependent variables. Okay. So for multiple linear regression, it is actually an extension of the simple linear regression that allows for more than one independent variable. More than one independent variable. Okay. So multiple regression can be used to predict or explain the behavior of a dependent variable y based on the values of multiple independent variables. Say you have x1, x2 up until xn. Because in our daily life, we don't have only one independent variable. Normally, we have more than one independent variable that will determine the dependent variable. So, in this case, the multiple regression model will multiply the independent variables. Let's say you have, this will be the model, the what we call it, the basic model for uh, multiple linear regression. So in this case, you have x1, x2 up until xn, and each b over here, this is the coefficient, okay, to the associate independent variable b1, b2 up until bn xn. A is the intercept, as always. So example of analysis using the multiple linear regression model. For example, we want to estimate the daily electricity consumption for a conditional system that is based on daily temperature, daily humidity, daily wind velocity in previous day temperature. So in this example, we have daily electricity consumption. This will be your y. Okay. And your x will be daily temperature. This is your x1. Daily humidity is x2. Daily wind velocity is x3. And previous day temperature is your x4. So in this case, we have up until 4 independent variable. Okay. So another example is estimating participant reaction time in a cognitive task based on the number of hours they sleep the night before, IQ level, and their current modes. So we want to estimate the reaction time. Okay. And the associate independent variable is number of hours they sleep the night before, x1, IQ level is your x2, and current mode is your x3. So this will be another example of using the multiple linear regression model. You have one y, one independent variable, and we have more than one independent variable. Okay, so this case we have the sleep, a number of hours the night they sleep before, and then the IQ level and also the current mode. So another example is estimating the weight gain using various levels of dietary supplements, exercise, and behavior modification. So weight gain is your y, and the factor is your dietary supplement x1, exercise x2, and behavior modification is your x3. Okay, so these are example of what we call it a multiple linear regression model. It is actually extension from what you learned in chapter 6, the simple linear regression model. And we are still dealing with linear. Okay, that is why you have x1, x2. You don't have to the power of 2, to the power of 3, and so on. So from here, it depends. If you have two independent variable, you will only have b1 x1 plus b2 x2. If you have more than 2, so you will have up until x3, x4, and even xn. Okay, so there are steps involved in how we are going to check whether the relationship is linear or not. First thing first, if you have to do the plotting. Okay, so in this in your syllabus, we will only focus on two independent variable. Okay, and bear in mind, this chapter is not going to be assessed in final exam. Chapter ni tak masuk final exam. Dia hanya di-assess dalam soalan, dalam assignment. It will only be assessed in the assignment. If you refer question 2 in your group assignment, there is a question about multiple linear regression model. So why it's not going to be in your final exam? Because the calculation is very tedious. That's why we are going to straightforward use Excel for all the calculation. Okay. So bear in mind, chapter ni tak masuk dalam final exam. Dia ada masuk dalam soalan assignment awak, soalan 2. And then dia tak masuk assignment sebab calculation dia sangat-sangat tedious. So we are going to use Microsoft Excel straightforward. Okay. So, and in your syllabus, we will only focus on two independent variable. So this will be the the what we call it the multiple linear regression model for two independent variable. You have a plus b1 x1 plus b2 x2. Okay, by which y is the dependent variable. X1 and x2 represent the two different independent variable. So in this, if you refer to your assignment, there are two variable. The independent variable is your CGPA. The independent variable is number of hours student sleeps, and another one I could not remember. Okay, so the same goes for this one. It will only involve two model, x1 and x2, represent the two different independent variable. A is the intercept value. And B1 and B2 represent the two regression coefficient. So if you are dealing with simple linear regression, we have only y equal to a plus b1 x1. But in this case, there's an additional term, that is x2 as your independent variable. So that is why we are going to have y equal to a plus b1 x1 plus b2 x2. Okay, so b1 and b2 represent the two regression coefficient. Okay, clear so far? Any question? Nobody okay? Tak ada. Okay. So, the next one, let's take a look into the coefficient, how we are going to interpret each coefficient in the regression model. So, A is the intercept value, and B1 measure the average change, the increase or decrease in Y corresponding to a 1 unit change in X1, while X2 remain constant. Okay, the same goes with the simple linear regression. B1 will estimate the change in Y, provided that X2 remain constant. Okay, because by is the coefficient for x1, and b2 will be the same. The average change in y corresponding to a 1 unit change x2, okay, because b2 is the coefficient for the x2, while x1 remain constant. So what will be the change that is associated with 1 unit change of x1 and x2? So this is how you interpret the coefficient. Okay. So this is the steps involved before we conducting the regression analysis. First, determine which one is your independent variable, x1 and x2, and which one is your dependent variable, which one is your y. And then use scatter plot to check linearity between y and x1 and y and x2. The relationship must be linear to contribute to the model. Meaning that in step 2, you are going to plot x1, you are going to plot x1 versus y. And then you plot the relationship should be linear. Meaning that for the graph of y versus x1, you are going to get a linear line, a straight line. And then you have to plot as well x2 versus y. So you do the plotting, determine where's the location of each data point. And then check the relationship. It should be linear. Only if both of the plots are linear, then only you can use y equal to a plus b x1 plus b2 x2. Okay. Otherwise, it will be not appropriate to use the linear model. Okay. Then for this one, use scatter plot to check the multicollinearity between x1 and x2. The relationship between x1 and x2 must not be linearly or highly correlated. Independent variables that are highly correlated are redundant. Only one should be used in the analysis. Meaning that you are going also to plot x1 and also x2. So the relationship should be linear. Meaning that for this plot, you should get a random plot. There is no single pattern for the relationship between x1 and x2. Then we can say that there is no multicollinearity. Multicollinearity is meaning that there is no interaction between x1 and x2. So if there is no multicollinearity, meaning that x1 and x2 are independent. The value does not depend between each other. Okay. So these are the 3 steps involved before we run the regression analysis. Okay. Then let's take a look into the estimating of the coefficient. So because in your table, you are going to have this is your y, this is your x1, and this is your x2. Okay. So if you refer to the previous model, simple linear regression, you are going to have SSXX, SSYY, and so on. So the same goes for this one. So you are going to have sum squared of y, so y squared, and summation of y to the power of 2 over n. So you are going to have one column for y squared over here. And then you are going to have summation of x1. Sum of squared for x1. So you have another column for x1 squared. And then you will have another one, x2 squared. Sum squared of x2. So you will have x2 squared column as well. And then you are going to have x1 multiplied with y, the summation. So another column, x1 multiplied with y, and also another column of x2 multiplied with y. So you take the total down here, the summation. So you are going to have all the summation for y, x1, and so on. Then you can include in the model, in the calculation, in the formula. So if you see from here, it's very tedious. You have to calculate y squared, x1 squared, x2 squared, and then x1 multiplied with y, x2 multiplied with y. That is why this chapter is the best to use software automatically. without using your what you call it, a calculator. Okay. Then we have also another one, x1 multiply with x2. There is another coefficient that we have to calculate. So from here we can get the value for B1 and also B2 because we want to find the coefficient in the model. What will be the value of A, what will be the value of B1 x1, and also what will be the value of B2. So these are the formula. Still we are using the least square estimation. So you have to use sum squared over here. And this is the formula for B1, this is the formula for B2, and this is the formula for A. A equal to y bar, which is the mean of y, minus B1 x bar 1, minus B2 x bar 2. Okay, so you are going to estimate for each of the coefficient. Okay, clear so far? So from here, we have sum squared of error, sum squared of total, and also sum squared of the regression line. So SSR, this is the formula, B1 multiplied with sum squared x1y plus B2 sum squared of x2y. So sum squared of regression is measure of the amount of variability in the dependent variable that is explained by the independent variable. And then sum squared of total give you the total sum of squared that tells how much variation there is in the dependent variable. And then sum squared of error, it will give you the error sum of squared. It tells the amount of variance that is not explained by the regression model. The smaller the SSE, the better is the regression model fit the data. Okay, so the best fit, how we can determine that the regression model that we get is best fit to the data by using the sum squared of error. So to get SSE, we have to find SST and also SSR from here. And you can get all of this value directly from Microsoft Excel as well. So estimation of coefficient, R squared is coefficient of determination. It also measure how good is the model fit to your data. Meaning that kita nak menjawab persoalan betul ke model ni benar-benar sesuai untuk data. Okay? Is the model is really suitable for the data that you have. So from here, R squared also measure the strength of the relationship between the regression model and the dependent variable by taking the value between 0 up until 100% in scale. If R squared equal to 0, meaning that a model does not explain any of the variation in the dependent variable around its mean. And if your value of R squared is very close to 100%, that means a model that explains all variation in the dependent variable around its mean. So meaning that the model is really suitable. The closer the value of R squared equal to 100%, the better is the fitness of the model to your data. That is the idea of coefficient of determination. So from here, we have this one. The adjusted R squared, by which adjusted R squared is the modification from the formula of R squared, by which it will be much more accurate. So it will adjust the value of R squared for both the sample size and the number of independent variables. Okay, when considering different multiple linear models, we could use this value to have the compare the models, meaning that if you have a number of independent variable, let's say you have x1, x2 up until xn, and we want to find which will be the combination that best fit the model. Let's say you have multiple linear regression model 1, model 2, model 3 up until model 10, for example. So we want to choose which model is the best that fits the data. So we will take a look into the value of this R squared or the adjusted R squared. The closer the value is to 100%, meaning that that will be the model that is best fit for the data, and that model will be the one that we are going to select compared to any other models. Okay, so that is the idea about multiple linear regression model. If you analyze the data directly using Minitab or maybe using SPSS or any other software, the output will give you automatically all the value. Even by using Microsoft Excel, you will have the value of R squared, adjusted R squared, and then you have the ANOVA value and so on. So that is why it is best to use the software rather than you do the manual calculation one by one for each the value of R and also R squared. Okay, dapat so far? That is the idea of multiple linear regression. That is the case if you have the linear model. Later on, we will take a look into the example. So another one, if the quadratic model. Apart from linear model, we are going to have this one. What we call it? If let's say, for example, we want to find the confidence interval for each variable, B1 and also B2. So it will be based on this formula. Okay, by using T distribution table, B1 will be B1 plus minus T alpha over 2 n minus 3 SB1. So SB1 over here is standard error for B1. So T alpha over 2 is from the T distribution table. SB1 is standard deviation, standard error for B1 calculated by this one, where Rx1, x2 is given by this formula. Okay, and SB2 will be equal to standard error square root squared over sum squared of x2 over 1 minus R squared x1 and x2. But if you are using software, you don't have to care about all the formulas because this value will also be given in the output. So we will get lower and also upper of the interval. So we can say the value of B1, the actual value is lies between this range on the upper and also the lower of the range given in the output. Okay, so this formula is just for you to know and also yeah, in case if you want to do the manual calculation. So the next one is the quadratic model. Okay, the quadratic model will be if you plot not all data follow a straight line. Quadratic model is useful when the relationship between the dependent and independent variable is parabola. Okay, we check using the scatter plot and then you get something like this. For example, this is your x and this is your y. So that is the case where we are going to have a non-linear model, which is a quadratic model. So quadratic regression adds an extra independent variable, that is the square of the independent variable. Quadratic regression also known as a second degree polynomial, meaning that you are going to have x squared. So this is the quadratic model. Okay, so from here, for example, we have data show the horizontal distance in feet traveled by a baseball hits at various angles. So the initial speed of the ball at the bat is a constant. So we have this is the angle and this is the distance. So in this case, angle is your x and distance is your y. So you want to check whether there exists or not the relationship between the angle and also the distance. So we do plot on the what we call it by using Microsoft Excel. For example, you do the scatter plot and you can see. So there is a curvature in here, meaning that there exists a non-linear relationship of angle and also distance. So in this case, because the relationship is non-linear, so we suspect that it will have a what we call it x squared terms, the quadratic model term. So the model will be y equal to b plus x squared, b plus x plus C multiplied with x squared. Okay. So the scatter plot show that the angles of the baseball is having quadratic relationship with the distance, quadratic relationship with its distance level, because the plot shows a curvature compared to any other linear. So you have this line over here. There's a curve over here. So we suspect that there exists a quadratic relationship between x1, between angle and also the distance, between x and also your y. So for this case, that is why it's very important for you to do the scatter plot, because scatter plot is for the first step, the initial step for you to check whether there exists or not the relationship. Is the relationship exists? Is it linear or is it non-linear? Okay. So the next one, from here, this will be the form of quadratic regression. Y equal to A plus BX plus CX squared. So you have another term here of CX squared to represent the quadratic term. Okay. Y is the dependent variable, X is the independent variable, A will be the intercept, B will be the linear effects on the parameter, and C will be the quadratic effects on the parameter. That is why you have the term of X squared for the quadratic effects. So for this case, to develop the model, of course, you have to do all the calculation, all the sum squared. So if you refer from here, we will have sum squared of x, sum squared of x squared, x multiplied with y, x cubed, x squared y, and also x to the power of 4. So the calculation is tedious as well. That is why we are going to make use of what we call it, Microsoft Excel, to get the output straightforward, so that you will get the value of A and B. So you substitute all the sum squared in the formula. So you are going to have, this is your A, this is your B, and this will be your C, by which B x bar, this is the mean, and this is a summation of x squared over n, this is not the mean. Okay, summation of y, this is y bar, the mean. So from here, this is your SST, SSR, and also SSE. So we will get coefficient of determination equal to sum squared of the treatment divided by sum squared of the error. Okay, sum squared of the total. So coefficient of determination, the same as the linear model, is going to calculate how best is the quadratic model to fit your data. The closer the value to 100%, the better is the model to, what we call it, to fit your data. Okay, so adjusted R squared, the same as multiple linear regression. Okay, you are going to have 1 minus n minus 1, 1 minus r squared over n minus 3. So this is the formula for the adjusted r squared. Okay, so this is another example, and if you do the plotting, you will get from here, you will get, this will be the quadratic model. Okay, so you can use the what we call, you can use the model here to do prediction. That is the important why you have to find the model for the data for us to do the prediction. Okay, so that's it about multiple linear regression. Because the calculation is very tedious, we are going to make use of Microsoft Excel straightforward. Okay, so let's take a look into the application using Microsoft Excel. So you can open up your Microsoft Excel, and I have uploaded the notes in YouLearn for the practice session. So open up this one, practical session 3, okay, using Microsoft Excel for chapter 7. Dah download ke belum nota ni? Have you downloaded the note or not yet?
Belum.
So I give you time to download the notes and then key in this data. Okay, we are going to analyze this data. Download the notes from YouLearn and then key in this data in Microsoft Excel. So I give you 5 minutes to key in and also download. Make sure you try, okay? Because later on, you can do your assignment. Question 2. Key in data in Microsoft Excel. So we just want to find the model and answer all the questions. So those who are not yet download the notes, you can download this one in practical session part and then key in this data. We have 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 10. 5, 1, 2, 3, 4, 5, 25 data. Okay. So you have speed, pause time, and also good put. So which one will be your Y? Which one will be your X1? Which one will be your X2? So download and key in the data. I give you time up until 10:45. Okay, done kelas? Dah ke belum?
Halfway.
Okay. Okay.
Sekarang di put output.
Okay.
Put, sorry.
Done ke belum?
Sudah.
Omar done? Jeremy?
Yes.
Not yet.
Yes, yes, done.
Done. Okay. I give time for some others. We will do the analysis on 10:50. Okay. So another a few minutes for those who are still keying the data. Okay, I hope everyone is done. So if you take a look into this data, this is the data is actually the same as in example in the slide. Dalam slide chapter 7. So ini example yang sama. So in the slide you can refer for the manual calculation, but in here we are going to straightforward use the Microsoft Excel to analyze the data because we already have the software. So what's the point that you want to waste your time using the manual calculation? But if you wanted to refer to the manual calculation, I have put the what we call it the slide in the slide of chapter 7. Okay, so let's take a look into this question. A mobile ad hoc computer, a mobile ad hoc actually, this is not as computer network consists of several computer nodes that move within a network area. Often messages are sent from one node to another, and we wish to predict the proportion of messages that will be successfully delivered, which is called the good put. So this is the output that we want to have. How many successfully delivered message? So it is actually the good put. So in here, straightforward, you know, good put is your Y. Okay. So it is known that the good put is affected by the average node speed and by the length of time that the node pass at each destination. So from here, the node speed will be x1 and the pass time will be your x2. So we are going to have the multiple linear regression. So table besides presents average node speed, average pass time, and the good put for 25 simulated ad hoc networks. So the first question, plot the scatter diagram to visualize the relationship between all variables, meaning that we are going to plot the scatter diagram of x1 versus y, okay, and then x2 versus y, as well as x1 versus x2, okay, and then fit the multiple linear regression model. So second question is, what will be your y? A plus b1 x1 plus b2 x2. So what will be the value of b1 and also b2? And use the model gain to predict the good put for a network speed of 12, meaning that when your x1 equal to 12 meter per second and when the fast time is 25 seconds. So when x1 equal to 12 and x2 equal to 25, what will be your y? So we are going to analyze this data by using Microsoft Excel. Okay, so first key in your data. Okay, this one, key in your data and select your data. Go to insert, select the scatter plot, plot x1 versus y, and then plot x2 versus y. So the steps is there. So let's go to my Microsoft Excel, and then I have practical session 3, this one. So example 2.1a. So this is the example how we want to do the plot of y versus x1 and also x2. First, select your data. Okay, so my data is speed, and also I press speed versus y. This is my good put. Good put versus speed versus good put. Okay, select these two columns. Okay, and then insert, go to insert, and this one. You will see XY scatter. So select that one and then select the first one. Okay, so you are going to see this will be the plot. Okay, so 5, 10, 15, 12, and so on. So this will be the plot, and this is not clear. I want to change to something clear. So maybe something like this. Okay, so you will get, this is the what we call it, the plot. So dapat tak yang lain? Did you get the plot? Select speed and then you can press control, select good put. So you select those two columns. Dapat yang lain? Then you can add axis titles, axis title. So primary vertical, primary horizontal. So this axis is for the speed in meter per second, and this axis is for the good put, by which it is in terms of percentage. Okay, so let me make it bigger, this one as well, make it bigger. Okay, so from here the title is a plot of speed in meter per second versus the good put in terms of percentage. Okay, and I want to put the trend line so that I know that this, is it linear or not. Okay, so it can say that there exists a linear relationship between the speed and also the good put. So this is the plot of x1 versus y. Dapat tak yang lain? The rest, do you get the same plot as mine? Amira, Afina, Irfan? Okay. Jeremy dapat tak? Ay, senyap je duduk dah ni, dapat ke tak ni? Cik Feng dapat ah? Dapat Jeremy?
belum. Doctor, can you
Okay.
repeat how you choose X1 and Y?
X2. Okay, sure. first you select X1 and then at the same time you press Control, because I'm using Mac. Actually for Mac it's Command, but for Windows I think press Control and then select this one. Try press Control, otherwise press Shift without letting go the speed.
Yeah, okay, thank you.
So press Control, is it? Or Shift?
Yeah, Control.
Control, okay. Okay. So if you want to select this one, select speed and then press Control without letting go that one. You select good put. Okay. So you can select these two column. Then go to Insert. Choose this one, Scatter. Kalau yang tak boleh tadi, press select speed, lepas tu tekan Control and then tekan juga select good put tanpa lepaskan speed tu. Masa tekan Control tu, tekan Control, select that one. Okay. Then go to Insert, Scatter. So choose this one, Scatter. You will get this plot. This is the plot of speed versus good put. Okay. So you can change, let's say I want to see something clear. So this one will be more clearer. So add chart element. So I put the horizontal and also the vertical axis, because otherwise your chart will not be complete. So you need to rename. X-axis is for your speed in meter per second and the Y-axis for your pause time. Pause time, that is in second. Okay, seems like it's too small, so I'm going to make it bigger. Okay. So this is the plot of speed in meter per second versus good put in term of percentage. Oh, this is good put. Okay, then you can add the trend line because we want to see that the plot must be linear. So add trend line. So linear focus or add trend line linear. So you will get, you can see it is linearly correlated speed and also good put. Then this is X1 and Y. The next one will be plot of X2 and Y. So select your data and then repeat the process. Insert, scatter. So this one, you are going to have the second plot of X2 versus Y. Okay, so add chart element, put the axis on the horizontal and also the vertical. So this is the second variable that we have is the pause time in second versus the good put. Okay, good put in percentage. So you will get, this is a plot of pause time versus good put in terms of percentage. Then you can put the trend line. Add chart element, trend line, put the linear trend line. So you will get these two plot. Dapat yang lain? Do you get the same plot in mind? So there is another plot that you have to do, that is X1 versus X2. So those who are still working on the plot, you can refer this one. Plot of speed versus the good put, and also plot of pause time versus the good put. So we can see that this plot shows a linear pattern. So we can make use of the multiple linear regression. And then another plot, you have to plot x1 versus x2. It should display the random pattern. So yes, this is a very random pattern, meaning that we can follow the, what we call it, the multiple linear regression model. So x1 is the speed in meter per second. And this is the pause time in second. This is a plot of speed versus the pause time, okay, by which it shows a linear pattern, a random pattern. So we can make use of the linear regression model. Okay, dapat Jeremy dapat? Robani?
Dapat.
Okay. Haikal dapat, Kal? Haikal ada kita ni? Cipeng dapat
Doktor,
ya.
macam mana nak lukis straight line seperti
Straight
first
line,
example?
go to select, you double click on the chart, and then you can add chart element. Or can you share your screen? Because I'm using Mac. It might be slightly different from Windows appearance. Or you can share your screen, I can guide.
Saya join lagi
Share.
sebab saya guna handphone.
Oh, okay.
Yeah.
So otherwise, if you are using Windows, you can click the chart and there is a plus sign over here. So you can add the trend line over there as well. Nadira dapat tak? Oh, Rabbani dapat?
Dapat, Doktor, dapat.
Share screen Rabbani? Nak tengok trend line.
Sekejap.
Halo doktor, saya share screen.
Okay. Okay, Cipeng akan share screen.
Sekejap sebab table saya hilang.
Okay.
Saya
No
cari.
problem. Takes your time. So it's good if you have any question, you can ask directly and don't hesitate, okay? Because otherwise, you have to do this, to use this, what we call it, this Excel using for your assignment. Okay, very good, Cipeng.
Sudah.
Where is it? Is it book 1? Book 5?
Yeah, sorry.
I can't see your Microsoft Excel.
Tak dapat.
Tak nampak.
Sekejap sebab saya sudah share screen.
Just share sekali.
So there's a question in chat from Jeremy. What's the difference between linear and linear forecast? Okay, this one. Sekejap sekejap lagi saya jawab dari that one Jeremy. So if you double click the what we call it?
Double.
That one. And then is legend chart title data. Legend ada apa-apa tak?
Legend ini.
Okay. Sepatutnya ada lah. Legend tak ada apa-apa. Vertical that series tak ada apa-apa.
Series.
Horizontal bar. That one trend line.
Trend line.
You.
Oh, ini.
That one. Okay. Dia dapat So you can repeat for the rest of that one. So it depend on version. Sebab Cipeng guna version lain. Kalau macam saya guna dekat Words pun lain, dia ada tanda plus. And then if I use my Mac, it will be different. So there's a question over here from Jeremy. What's the difference between what's the difference between linear and linear forecast? So if you refer from here, there's the chart element, the trend line. You have linear and also linear forecast. Linear is just it display the straight line between the data. Okay, and if you put linear forecast, you will have additional point over here. So for example, this is I select linear. Okay, for my chart over here, add chart, I choose the linear. So it will be okay, so if it is linear, you can see it will only up until this side. Okay, and if I select it only up until your data point, and if I select add chart element, trend line, linear forecast, then you will have additional this one. I will have additional line over here, meaning that the linear forecast give you the forecast value based on the data, based on the trend line. Okay. So kalau awak ambil linear forecast tu, dia akan bagi nilai yang dia predict juga berdasarkan data tu. That's why dia ada tambah sikit daripada keluar sikit daripada data. Okay. That is the difference between linear and also linear forecast. So it's forecast lah. It add up a forecast area for this one. Okay, dapat So referring to the slides, this is the interpretation. Okay, so from the plot, scatter plot, it appears that there exists a linear relationship between speed and also pause times towards the good food. And another plot, it shows that there are random pattern. There exists a random pattern, meaning that we can proceed with the what we call it, with the multiple linear regression model. So if you refer from the second question, fit the multiple linear regression model. So this is the second question. For the second question, we want to find what will be your y equal to a plus b1 x1 plus b2 x2. So there are two ways in here, meaning that first you can calculate using formula. So you have your x1, x2, and then your y over here. So you can add another column for x1 squared, and then you have another column for x2 squared, and so on. Okay, and then you add in the formula. You add in this formula for all of the value. You manual calculation for SS, YY, and so on. So you will get the value of A, B1, and also B2. So there is another way. So if you want to use that steps, so I have put in here. So step 1, insert new column, and then insert formula to calculate x1, x2, calculate the total for each column, okay, and then insert the value the value for each total in the formula to get the value of A, B1 and B2. So you have the new column for x1 squared, x2 squared, y2 squared, x1 multiply with xy, x2 multiply with y, x1 multiply with x2. So the total down here, and this is the average. Substitute all the value that you get in this formula as well as in here. So you will get the value of A, B1 and also B2. So there is this can be said as the manual way. You can try this one later on by yourself, but I want to show to you in a very, what we call it, in the faster ways, by which we will just fit the multiple linear regression model for this one. So by using analysis toolpack. So we will go to data analysis, select the regression and then select your X and Y data. So we will try this way by which everything is there for you. So we don't have to waste our time to do the manual calculation. So for this one, we will do the analysis toolpack. Okay. For the manual calculation, you can refer from the slide. Okay. You can add the x1 squared column, x2 squared column, and so on. So we want to use the analysis toolpacks. Go to data, okay, and then select your data analysis. Okay, data analysis. So this one. So you have ANOVA and everything. Select the regression. Okay, go to data analysis, and then select the regression. Then click OK. Okay. So select your data. Input Y range. Where is the range of your Y data? So input Y range. Just select your Y data. 95.11, 95.111 up until 90.101. Then click on the input explain for the next box. So key in your X data. Okay. So just select the two column for X1 and X2 for your X data. So you don't have to change anything for the level and confidence level. So you can select, we want to have 95% confidence level, and then click on the output range. So where you want to have your output, click on the box. I want to have the output next to the table. So I just select column F, row 3. Okay, then Excel will put the output over there. Click OK. Then you will get. So this is sum squared, SSR, SST, and SSA, and then you have all the coefficient in here. Okay, so this is multiple R, R squared, adjusted R squared. So you, with only one click, you can get everything. You don't have to do the calculation, the tedious calculation one by one. Okay, so I widen the column so that you can see clearly the T statistic, the lower 95% confidence level, upper percent confidence level, and so on. Okay, but the decimal place is a lot. So I select all data. I go to home and decrease decimal because I want to have only 4 decimal place for this one. So this one. Okay. And the same goes for multiple R over here. I decrease the decimal so that I can have up until only 4 decimal place. Okay. So this is the result. From here, from the result over here, you can have this is your A. Okay, draw this one. So this is your A, this is your B1, and this is your B2. So it's very simple. You don't have to calculate one by one. Okay, this is multiple R, that is R squared, R squared, multiple R, this is R squared over there, adjusted R squared, the one that I showed in the formula. So this one, adjusted R squared. Standard error, and you have n equal to 25. So this is SSR, sum squared for the regression. And then you have, this is your residual, SSE. And this is your SSD. So you don't have to care about all the formula. Everything is here. Okay, if you want to run the hypothesis testing, this will be test statistic. And this will be the p-value. Okay, so this is the, what we call it, the confidence interval as well. The one that we calculate using the B formula, B1 plus minus T alpha over 2. So this is the lower and this is the upper. So for this case, your model is good put, or Y equal to 84.0395, okay, minus 0.4568 x1 plus 0.3770 x2. Okay. So dapat yang lain? This is the multiple linear regression model by using data analysis in Microsoft Excel. So it's very simple. With only one click, you can get everything. And this is R squared. How good is the model fit the data? So it is only 62%, around 62%. The suitability of the model, the multiple linear regression model, to fit the data of good put versus the speed and also pause time. Okay, dapat yang lain? Oi, dapat tak?
Doktor,
Aha.
saya tak tahu data analysis di mana. Tadi saya cari tapi tak.
Cuba share screen. Those yang tak ada data analysis boleh tengok ni Cipeng punya ni. So tak ada data analysis Kalau data tak ada. Okay, pergi dekat file. Option.
Option.
Yes.
Okay.
That one. Okay, regional format setting. Try click that one. English. Cancel.
Cancel.
Cancel. Or pergi dekat file tadi. Info. Kalau about.
Sorry?
About. Term of use, third party, privacy and cookies, privacy setting. Option dia tak ada Because this one using web Okay, so kalau you using, maybe because you are using web, that's why dia tak ada data analysis punya toolpack.
Kena
Dia you kena add on. Kalau you install dia punya software, Microsoft software, option, and then dia akan keluar. If you click option, that one, dia akan keluar. Kita boleh add in. So this one, I think maybe because of the web version, that's why there is no add-ins. Kalau try search ada tak? Dekat that one. You pergi balik dekat Excel.
Okay.
Klik je. Search cuba tulis data analysis.
Tadi saya
Analysis. Okay. So it's only appear analyze data. Analyze data tu keluar apa? Analyze data. It will display the direct analysis. Dia tak ada analysis punya toolpack. Rasa you kena install ni lah nanti.
Ya.
Untuk assignment lah. You kena ambil Microsoft, install dekat you punya laptop, and then boleh dapat analysis toolpack. I think this is because the web version. Okay lah. Yang lain ada tak? Okay, very good Cipeng. Yang lain ada tak? Problem. Kalau ada yang tak ada data analysis. Boleh share screen? Or anyone? Omar, do you have the data analysis to pack?
Yeah, I have.
Oh, okay. Nik Bazri semua ada? Yongjun?
Okay.
Okay ya? Abang ni okay. So, that's the
Okay.
case. Otherwise, you can, what we call it, you can go to PPPK, Pusat Komputer, something like that. Okay, and install. That's the, what we call it, because if you are using the web, sometimes the Microsoft limited because they want us to buy their product. That's why they limited the access that we have. Okay, so nanti Cipeng boleh pergi dekat pusat komputer lah. Install Microsoft punya, what we call it, Microsoft punya application. Okay, so that's it about the model. So if you refer, I have also upload in the slide. So you go to regression, you insert your data, okay, your X data, and then you can get the output. So from here, this will be the model. So y hat equal to 84.0395 minus 0.4568 plus 0.3770. Okay, so this is the model is from here. You get this one, coefficient. Okay, so the rest of the reading adalah yang saya terangkan tadi. It's the one that I told you earlier. This is a multiple R squared, adjusted R squared, SSE, and so on. MSE and the F. So these are ANOVA if you want to do the hypothesis testing, which is beyond the scope of your syllabus. Hypothesis testing on the suitability of the model. Okay, but for your syllabus, we will only find up until this one, and also the confidence interval. So the same goes if you calculate using all of this, using manual calculation, you will still get the same answer. Okay, you will still get the same answer. This one. So this is the model. Okay, dapat eh? So the next question is question C. Okay. Question C is that use the model gain to predict the output for a speed of 12 and pause time 25. So this one you can't calculate using Microsoft Excel. So we have to calculate manually using the, what we call it, using calculator, or you can use Excel as well. This is where the case is x1 equal to 12 and x2 equal to 25. So for this case, let's say I want to calculate using Microsoft Excel. This is the model that I get. So if question D, given x1 equal to 12 and x2 equal to 25. Okay, so I will just type in here the good put equal to, okay, and then I go to the next box. I put the formula equal, the first one is 84.0395 minus 0.4568 bracket 12, okay, and then no bracket, multiply with 12, star 12, okay. So then I have bracket over here. Then plus another bracket 0.3770 star with 25. Okay, close the bracket. So this is the formula, and then I press enter. So you will get the good put equal to 87.9829. Okay, when the good put, this one, when the speed is 12 and the pause time is 25. Okay, so dapat eh? Or you can manually calculate using your calculator. Okay, dapat kelas? Umar, do you get it? Yes. Okay. So any questions so far on this one? So for your assignment question 2, you need to do a survey, select the, what we call it, get the data, and then key in the data in your Microsoft Excel, and then you can use the analysis toolpacks. Okay, just go to data analysis and then run the, what we call it, the multiple linear regression model. Okay, yeah. So the next one, okay, we have, so this is the interpretation, the solution is over there. I have put in the, what we call it, I have put in the slide. So this one, so if you want to have 95% confidence interval for the coefficient of speed, so if you are using the formula, this will be the formula I showed earlier in the slide. B1 plus minus T alpha over 2 n minus 3 S B1. Okay, so you will get this one. Or by using Microsoft Excel, you will get, this is the confidence interval. So you don't have to calculate, everything is there. Okay, you don't have to use the manual calculation, you will get automatically the confidence interval is there. For the, what we call it, for the coefficient of B1, confidence interval for B1. Then the same goes for confidence interval for B2. If you're using formula, substitute in there, you will get that one. Or automatically you will get from the output. This one, 0.9 and 0.551. That is why Excel make your life much more easy. You don't have to do the manual calculation, that is very tedious. Everything is there in the Microsoft Excel. It is the same actually. This one is the same for this one. Because we select the confidence interval, that's why it gives the, what we call it, double the output. Okay. So we have another one, the quadratic. So the given data show the horizontal distance in feet traveled by a baseball hits at various angles. The initial speed of all the ball at the bat is constant. So plot the scatter diagram for the given data and interpret the relationship, and then fit the best model for the data. So this is the example from the slide as well. In this example, we want to have y and also x. We want to see the relationship between y and x. So key in data in Excel. I will show you how to fit the quadratic model. It will be slightly different from the multiple linear regression model. Okay, key in data in your Microsoft Excel first. You will run this exercise. So key in your data, and then we will see how to do the, what we call it, quadratic regression model, because you are going to have x squared term for this one. So key in dulu data. Done ke belum?
Almost.
Okay, Cipeng done. What about the rest? Dah ke belum? Omar done or not yet? Okay, done everyone. So let's go to Microsoft Excel. Discuss. So you already have key in your data. So from here, we go to Microsoft Excel. It will be this one, the quadratic model. Okay. So the first question stated in there. So from here, distance will be your angle will be your x, and distance will be your y. Okay. This will be your y. So from here, the first question is that plot the scatter diagram and interpret the relationship. So just repeat the steps. Okay, home, select your data first. We have your X data and also your Y data. Okay, insert and then you have the scatter diagram. Okay, so kita balik pula. Switch row or column. Select data. So select data, distance and also angle. Okay, insert, scatter. So you get this one. And then switch row or column. Apa pasal dia tak switch pula ni? Okay, select data. X values equal to select data. So X values is, this is my X values, okay, and then Y values is this one, my Y values. So click OK, then you will get, this will be the plot. Okay, so let's say I want to have something like that. So yang lain dapat or otherwise you can just change the column. You type X first and then you paste the Y column next to the X, or otherwise you can switch this one, select data and change the data. So this is the plot, and from here, if let's say I want to have the what we call it, the axis title, so I can put the primary axis and also the primary vertical. So for the primary axis, this is the angle, okay, in degrees, and this will be the distance in feet. Okay, so this is the chart title is plot of angle versus distance. So you get this will be the plot. So you can see there exists a quadratic line for this plot. Okay, dapat eh? So if you copy and paste the data, so we can get, this will be from the scatter diagram. Okay, from the scatter diagram, it shows that there exists a quadratic relationship between angle and distance, because from the plotting you can see that there is one line over here, one quadratic line. Okay, so there exists quadratic relationship. So the quadratic polynomial regression model is best to fit the data. So we are going to fit with this model. Y equal to A plus BX plus CX squared. So you will have a term CX squared. In Microsoft Excel, they can't read the data directly. So we have to create a new column for X squared over there. So yang ni dapat tak? Omar, do you get the same plot as mine? Izham? Bazali? Bani? Dapat tak? Kita dapat yang lain? Senyap je. Senyap je, saya zoom dapat dah. So the next one, so we want to fit the best model for the data. In this case, we are going to insert a new column and calculate X2. And then we will go to the regression, data analysis, and then select your data. So for this one, back to your Excel. So I have to create a new column for the X2. Okay, because it shows a quadratic. So from here, this will be a new column, X shift 6 2, which represent X squared. Or I can insert equation over here. So it is actually X squared. Okay. So this one. So I put a new column of X squared over here. So we need to calculate manually. Equal, this is your X, shift 6, shift 6 untuk for their power, and then 2. Okay, insert that formula. Then you can enter and you can just drag everything down up until the last data. So Excel will calculate automatically for the X2 column. Okay, create a new column for X squared. So you put equal sign and then select the first data of X that is located in C6 and then shift 6, tekan shift 6 untuk kuasa. Shift 6 for power and then press 2. So you are going to have that data. C6 to the power of 2. Click enter, so you will get 100. Then you can just drag everything down. So this is the column for X squared. Okay, because Excel automatically fit in the data. So you have to manually calculate for the column of X squared and then fill in the data. Done with this one? Done with this step or not yet? Done?
X square belum.
Escape belum? Okay. So this is the formula. C6, select your first data, shift 6 for the power, shift 6 for the power and then 2. Press enter. Done. Nanjira done. Okay. Okay, Cipeng done. Okay. So then go to data and then data analysis. Okay. So we will repeat the previous step. Select regression and then select your data. Click regression and then click OK. Okay. Okay. So key in your data, XY data and so on. So for this one, input Y range, I click on the box and I select. This will be my Y data. So click dekat box tu and then select Y data awak. X range, click on the box and select both X to the power of 1 and X kuasa 2 and X to the power of 2. Okay. For X data, select both X and also X squared. You put in the input X range. Okay. Select data X dan juga X kuasa 2. Put in the X range. And then output range, click on the box. Let's say I want to put somewhere in F6. Then just click OK. Then you will get the output. So this will be the output. Okay. So this is multiple R, adjusted R squared. And then we have the 13 number of observation. So this is the ANOVA, sum squared, SSR, SSE, and also SST. And this is the coefficient. So coefficient, I want to reduce the decimal place. I select and then I go to home, decrease decimal. Okay. So you will get, this will be the model. Coefficient is represent the model. So from here, coefficient over here, this will be your model. Okay, this one. So you will have this coefficient over here is your model. So you have the model is that y equal to negative 21.8977 plus 14.5212x1. Okay, 5212x plus minus 0.1737 x squared. Okay, so you will get this will be the model. Okay, so the what we call it, the confidence interval as well given by this one, and then you have the ANOVA table if you want to use the hypothesis testing. Adjusted R squared, this is the model is 99% accurate. Okay, 99% fit to the data, which is very good. And this is the adjusted R squared is 97%. Still, it's above 90%, which is the model, the quadratic model is best fit to the data of distance and angle. Okay, so if you refer, I put the steps in here in Microsoft Excel. Okay, you put x squared and then you get the what we call it, the regression data analysis, and then this is the model. Okay, this is the model which is based on the coefficient over here, negative 21 plus 14.45212x minus 0.1737 x squared. Okay, or distance equal to negative 21.8977 plus 14.5212 angle minus 0.1737 angle squared. Okay, so this is the quadratic model. So it's very simple if you are using Excel. Just go to regression. Okay, regression, click OK, and then select your data, and then you will get the output. So everything is there in the output. I put as well review exercise 3. You can try this one by using Microsoft Excel, and also this one, the quadratic model. This is from exercise in the slide. The answer is there in the slide. You can try by using Microsoft Excel. Boring-boring nanti kau buat lah. Okay, so any questions so far about the multiple regression? Next week class will be face-to-face because next week is the last chapter, chapter 8. So everything is manually calculated for chapter 8. Chapter 8 is very simple because it's a non-parametric. So the recorded version will be available in Microsoft Teams in files. You can refer later on if you want to do your assignment. And please remember, this chapter is not going to be accessed in final exam. Chapter ni tak ada dalam final exam. Okay, but please answer the question in question 2 in your assignment for this question. Okay, ada soalan so far? Any question?
Tak ada.
Tak ada. Okay, yang lain-lain?
Okay.
Omar? Okay. Omar okay? Young Jun?
Yes, okay.
Okay. So if there is no question, that's it for today. And I will see you next week on the face-to-face class. Okay, you can try the exercise, or if you have any question, you can later on see me and bring your Excel. Okay, that's it for today. If there is no question, that's all. So thank you, class.
Thank you, Doctor.
Okay,
Thank you,
welcome.
Doctor.
Thank you, Doctor.
All right.
Thank you, Doctor.